Hello, I welcome you all in this presentation related with the subject principles of industrial engineering, and we are talking about the quality control. Uh, all of us expect that we get the good quality products and services from those who are providing the products and services. Uh, but many times we find that the defective products or the poor services are offered by them. So, it is the responsibility of the management organization and those who are working in the organizations to control the quality of the product and services, so that they can provide the reasonably good quality products and services, so that the customers can be retained, business can continue to grow, profitability of the organization continues to increase, and therefore, it is very important that the quality of the products and services which are being provided by the organization is maintained properly, and therefore, proper quality management is needed. So, the quality management will be looking into the various ways what can be done for improving the quality. There can be certain the manpower training programs, there can be improvement in the machinery, improvement in the material control, the improvement in the inspection techniques. So, there can be various aspects related with the management of the quality. So, primarily it works on the like data based approach, means instead of using the experience and skills only, the data about the quality characteristics of the products and services is collected. So, what is important is the quality characteristics which are important for the success of the product and service, those are identified, and the data about those quality characteristics during the manufacturing is established, measured, identified. So, once the data is generated about the quality characteristics, that is looked into to see really what can be done for improving the quality. So, there are certain tools which are used to manage the quality, so that the organizations are in position to provide the good quality products and services to the customers, and these tools include like the first one, brainstorming, wherein all those stakeholders, whether management, shop floor people, customers, suppliers, distributors, all those people related with a particular product and service are brought uh, together, and uh, the exchange of ideas help in coming out with the way by which the quality of the product and service can be improved. So, it is about the discussions, interactions for gathering the ideas to look into a particular problem which is really very important for the sellability of the product or the profitability of the organization. So, the people are brought together for interactions, discussions, so that they can generate the ideas to look into the way by which the quality aspects related with the product and service can be addressed. The second is the check sheet. Check sheet is a simpler the tabular sheet which is designed as per need for collection of the data related with the quality characteristics which is of importance, so that the data is collected in understandable and presentable form. So, this is the purpose. So, as per the need, suitable check sheet is designed for collection of the data, so that it can be easily understood and the inferences can be gathered easily. Then there is a fishbone diagram, fishbone diagram. This is also called the developer of this diagram was Ishikawa, so also known as Ishikawa diagram. It is also known as cause and effect diagram, because it this is the diagram which uh, in which the team of all those concerned people analyzes the various causes for a particular effect. Effect may be in form of like poor performance, excessive rejection, bottleneck of in a particular assembly line. So, the effect may be the kind of the feature that is of interest, either to increase or decrease, like reducing the rejection or increasing the performance. So, so effect is mentioned on the right side, and then one line is drawn. This is like the central bone, looks like central bone of the fish, and then there are other bones are indicated like this. So, here the major these represents to the major causes like the procedure or the material or the worker or management. So, the first the major causes for particular effect are identified, and thereafter further through the brainstorming and through the discussions, the minor causes related with the major causes are also identified, and based on the based on the voting pattern or based on the in a democratic way, the minor causes are identified in such a way that the action can be taken on those minor causes to get the particular desired effect. So, basically it helps to identify the various causes which can lead to the particular effect, and then the most significant cause which is leading to a particular effect, that is also identified democratically, and then action is taken on those causes to get the suitable desirable effect. Then there is a Pareto diagram. Pareto diagram, this helps in prioritizing the various factors leading to a particular effect. Like there is some effect or the characteristic or the desirable feature which is in which organization is interested. So, these effects or the features may be influenced by a large number of factors, So, the data is collected to see really what is the frequency of occurrence for this effect due to a particular factor. So, like say there are many factors A, B, C, D, E, and what is the frequency of occurrence for a particular effect by a particular factor, that is quantified. And if it comes out to be like this, like a factor is contributing to the like say 50% of the time particular effect is caused by the A factor, then 10% like say 18% time the particular effect is caused by the B factor, then 10% is caused by the C factor, and likewise. So, this total percentage will continue to will keep on decreasing, and that is how it is quantified. Basically, the data is collected in such a way that what is the percentage of occurrence for a particular effect by a particular factor, that is what is quantified, and then plot is generated here. Like here we have the different factors A, B, C, D, in the order of their significance they are plotted. So, what we find that there can be like 50% here, then remaining the 20% say 18% is due to the B. So, this is how it is plotted, and when we plot it in cumulative manner, we find that like say 70 to 80% of the effect is being caused by these two factors. So, basically in Pareto diagram we are able to prioritize the various factors which are more important and having the greater effect on the certain desirable feature or desirable effect or undesirable effect which is to be reduced. So, basically the Pareto diagram helps in prioritization of factors, and then accordingly those factors are given more importance as compared to the other factors. This is also known as like a 80-20 uh, uh, rule, wherein 80% of the problems are caused by the 20% of the factors. So, there are very few factors which are mostly troublesome, and there are many factors which cause fewer problems. So, based on this, so means there are many 80% of the time the problem is caused by the 20% of the factor, like our 80% of the time goes in 20% of the activity. So, most of the time we are doing very few things. Our 80% expenditure goes in very few activities, while very less expenditure goes in many activities. So, this is a universal law which states that in this particular case 80% of the quality problems will be caused by the 20% of the factors. So, we need to focus on those 20% factors which are significantly affecting the quality aspect related with a particular product. So, so that is the Pareto diagram. Then we have the flow diagram. Flow diagram helps in this is basically a block diagram which shows the sequence of events during the operation or working of a particular machine or the entire manufacturing procedure being adopted for a particular product or to deliver a particular service. So, the block diagram will be indicating the sequence of steps and events in which the various things are done to deliver a product or service. So, once we have the better understanding of this, we will be able to relate it the kind of particular step, the way by which particular step can affect the quality characteristic, can affect the product or can affect the process. So, better understanding of the entire procedural aspects is possible through the development of the flow diagram for a process or for a product or for a manufacturing sequence. So, that is very useful in analysis. Then we have the scatter diagram. Scatter diagram basically like there are various factors and they have effect. So, effect may be of importance from the quality characteristics point of view. The various factors are affecting the various quality characteristics. So, what we want, like in x axis we have that factor that is affecting the quality characteristic. So, in x axis we mention the factors, and in y axis that particular quality characteristics which is of importance, and then plot between the two is developed. So, which may show the way by which the particular factor is affecting to the quality characteristic, and then to establish the particular relationship between the factor independent factor and the quality characteristic, we may go for calculating the correlation coefficient or can also do the regression analysis to see the kind of effect is there of particular factor on the given quality characteristic which is of importance, and that can be used for analysis. So, that is the scatter diagram, and the finally we have like the control charts. Control charts. So, the control charts is one of the tool related with the statistical process control. This is known as SPC. We know the variability is very normal thing, and this is something which cannot be eliminated. The two things will never be same. There will always be variation of one or other kind, whether it is being created by the God or they are being manufactured at the shop floor. So, when something being manufactured at the shop floor, the products like say the whatever products, if the same product may have lot of variation within the product itself or with the other products which are being manufactured in sequence. So, whatever the products on the or the services being developed, they will always vary from each other, and this is very much normal thing. But if the variation is within the limits, then everything appears to be simple, acceptable, and and it looks to be good, acceptable to the customers and users. When the variation in the characteristics of the product is too high, and when it goes beyond the acceptable limit, then people say no, it is not good, it is not working, and the things are rejected. So, the thing is, it works on statistical process control. This approach works on the idea of controlling the process. So, during the manufacturing, if the process is under control, then it will produce the products which are acceptable. So, means if the means is right and will also be right. So, if we do right things, then at the end we will get the right product. This is the concept of the statistical process control. So, the process efforts are made to keep the process in control, so that we can keep on getting the products which are acceptable and the rejections are minimized. So, we will see the statistical process control. In statistical process control, what we have, this is a method of measuring and understanding and controlling. It helps in measuring if the process is in control, it helps in understanding when what is going to happen or what is happening with the process as far as control or the possibility of loss of control. So, that so in that situation the products will be produced which may not be acceptable. So, and so understanding the process means what is its status, and if we can leave it alone and continue to make the things which are acceptable, and if it is going out of control, then what we can do. So, controlling the process. So, these are the three aspects which in which the statistical process control tool helps in manufacturing processes when it is applied, measuring the kind of status of is there of the process, understanding what is the status, if it is, if the process is doing well, and what can be done when the process starts going beyond the control. So, controlling the things, understanding the things, and measuring the things, measuring the status of the process, if it is doing good or not. So, when the SPC is applied to a particular manufacturing process, it helps in establishing the two simple things. One is to understand the process is in control or out of control, During the manufacturing process, when SPC is applied, we can understand, we can know. So, objective is to establish if the process is under control or if it is out of control. The second is, it also helps in establishing the process capability. If the process will be able to make the products of a given specification effectively or not. So, determining if the process can make the products of a given specification or not, that is assessed through the process capability. And if at all the process is going beyond the control, then when to take the corrective action and what type of corrective action is needed. So, the reasons for variation in the quality characteristics of the products being manufactured by a particular process are also established, and which help in taking the suitable corrective action. And SPC, the statistical process control, works on a certain assumption that whatever variation is there, that is very normal. Means the normal variation means there is somewhere the process, the characteristic of a particular product being made by a particular manufacturing process has got an average, and the distribution of that characteristic is very normal. So, this variation is normal, natural, it is non-random. Natural variation means whatever variation is there on the higher side, the same is the degree of variation in the lower side, and the variation is symmetrical and spread about the average both the sides equally. So, this variation is very normal and it is always there, it cannot be eliminated, but what can be done? This extent of variation can be reduced like this, the spread is reduced, the spread can be further reduced like this, but it will always be there. Now, it will depend upon like many times variation we are not able to quantify, then we say that no, two things are same, but actually it may not be. So, when we say that this difference in the characteristics being quantified we cannot measure because of our limitation, then we say that two are same. Actually there may always be some kind of variation which we may not be in position to quantify. That is why the variation will always be there, it cannot be eliminated, however it can be reduced. Excessive variation when it takes place during the manufacturing, then you will see that many things are being manufactured beyond the specification limits, beyond the acceptable quality, and then it leads to the lot of variation, a lot of troubles, like a lot of things which are being manufactured are not acceptable beyond specification, it will be leading to the wastage, and wastage the things being manufactured are just being sent to the scrap because of the very poor quality in terms of the dimensions, weight, characteristics, whatever important, and then so increased wastage or increased rejection will be leading to the increased material loss or increased cost. So, reduced productivity, making the product competitive. So, when the variation is less, it reduces the wastage, it reduces the cost because we will be reducing the waste, we will be increasing the productivity, and the number of rejections will be reduced. When the variability is really less, the variation in the quality characteristic is reduced like this. In that case, the process is the things will be manufactured with a very less variation, which will improve the quality of the products, its functionality, features, and that in turn will help in improving the competitiveness of the product. And once through the certain steps, if the variability has been reduced, earlier the variability was more, by taking the certain steps if the variability is getting reduced. So, keep on working continuously to reduce the variability, so that the process can be improved continuously, and this variation in the process is statistical. So, that then only we will be able to apply the SPC tools for taking the different steps and actions for improving the quality. As I said, the variation is very natural thing, variation is very normal, means it is always there, it is not something like which is very abnormal and can be eliminated completely, it is always there. Now, the variation may be small or large. If it is large, going beyond the acceptable limit, then we will reject, if it is small, then we will accept. And this variation is caused by the two types of factors. One is termed as like the chance or common causes, and the second is the spatial or assigning causes, the causes which can be assigned or fixed. The common causes are like very normal, like the little variation in material quality, little variation in the expertise of the worker, little variation in the kind of vibrations which are being offered by the machine during the operation, a little variation in the procedure. So, minor variation, minor things are always there and these cannot be eliminated. However, these can be reduced. So, the common causes are always there and they will be causing little random variation in the quality characteristic, and the management is supposed to work on reducing the common causes, so that the process in general can be improved. Once the process is improved, then the extent of variation being caused by the common causes, that will be reduced. When the assignable causes are present, like the worker is really not, he does not understand what is to be done, he is following completely incorrect procedure, incorrect tool is being used, method of processing is completely incorrect, means something wrong is happening while manufacturing and leading to the excessive variation, rejections, decreased quality. So, here we need to bring the process under control, and when we can bring the process under control, so that the excessive variation can be reduced and the unacceptable quality products can be reduced by through the reduction in variation. So, these are the special or assignable causes, and these are the chance causes and common causes. Now, I will summarize this presentation. In this presentation, basically I have talked about the 7 tools of the quality management, and what is the basic approach of the statistical process control for the quality control of the products and services. Thank you for your attention.